ladies and gentlemen, a very special guest tonight on the show. He's been on the show before, and he has some of the most amazing, comprehensive ideas about the evolution of the universe and potentially the cosmic catastrophe cycle. Dr. Paul LaViolette is an author of many amazing books, including my favorite, Earth Under Fire, as well as Secrets of Anti-Gravity Propulsion, Subquantum Kinetics, and many more. He is, I believe, the founder and CEO of the Starburst Foundation. You're looking at that screen right now. And welcome to the show, Paul. Is everything I said correct?
Yes. Yeah, I am the founder. It was founded in '84. Right after I got my PhD, I founded that because I felt it was important to inform the scientific community about the superwave phenomenon, because they were all had their head in the sand, basically, had no idea, no clue about this phenomenon. And we even did a outreach project, I think it was in '89. We sent material to the White House, UN, defense committees, and so on. We're saying if a superwave hit and its EMP hit the Earth, not to interpret it as a nuclear advance attack and start launching. You know, that was the concern back then in the '80s, when we were still armed to the teeth with nuclear weapons. And
all right, so let's go back to basics. The galactic superwave theory was your PhD dissertation,
right.
Correct?
Mm-hmm.
Okay, and so in this discussion, we're going to just generally go over the theory. Does the galactic superwave have a periodicity? Is it on a schedule?
Well, it's periodic phenomenon, and we found a record of it, the past occurrences in the ice core record, through the beryllium-10 that's deposited in the ice. Beryllium-10 is a radioactive isotope that's produced only by cosmic rays hitting the atmosphere. So it's ideal for recording cosmic events.
Back at university, when I was there, same exact time what this is occurring in '89, '90, I'm a stratigrapher, so we're doing paleoclimate work. We're working in basins and looking at outcrops all over, trying to connect the dots. And what we come up with and what we're working with is a hypothesis called the pack hypothesis. And because in the rock record, what you see is these catastrophic shifts in environment that repeat, and they repeat on a pattern of about 25,000 years, with major shifts every 100,000 years. And then if you look at the Vostok data, it's the same stuff we're seeing in there, 104,000 year beryllium peak, and with other peaks in between the major peaks. Now we were looking for a mechanism, and back then the mechanism was the wobbling of the Earth. Now, how the wobbling of the Earth causes more beryllium to fall onto our planet is anyone's guess. So the Milankovitch idea really doesn't explain it.
No.
But I think your idea may.
Yes. Yeah. So there's a background radiation that we get all the time. And so we're looking at peaks above background. So you'll see in the glacial ice record that the levels go along, and then suddenly it will peak up suddenly and go way above background. So those would indicate a time of a superwave event. Usually, I mean, supernova don't occur that frequently to be doing this. A fellow did an analysis with Fourier analysis of the record of beryllium-10 peaks in the Vostok ice core, totally separate study from what I was doing, and found that they recur on several cycles. One is around 12,500 year, another around 25,000 year cycle, and the other one was around 5,300. Or 56, 5,700, which plus or minus 400 or so. So for the accuracy of the determining the cycles, that actually embraced the Mayan cycle, which is very interesting. And in fact, there was the most recent superwave was a small one that occurred around 5,300 years ago. and the Mayan cycle started just a few hundred years after that. So that means,
What's
and that
interesting,
cycle has finished. So we're
and
sort of coming to another one now, supposedly.
yeah, now based on my studies in stratigraphy, these cycles are about 20, each stratigraphic cycle that we look at in the field is about 25,000 years. It consists of two parts, what we call a high stand and a low stand. There's a sea level fall surface in the middle at the 12.5 mark. So what you have is one high stand of sea level environment, followed by a sea level fall surface, and then a 12,000 year period of a low sea level. And this could be a fluctuation of 100 meters at the max, and that's what we saw at the Younger Dryas event. So it seems like this cosmic event is causing either sea level to go up or to go down.
Well, you have even shorter cycles during the Ice Age. You observe them. They're called Dansgaard-Oshur events, where it goes from Ice Age temperatures down to interglacial temperatures in a matter of a decade or so. And then suddenly flashes up to be cold again. During the Younger Dryas, there were a lot of those happening.
I've done a paper. I did a podcast on the idea that during the Dalton minimum in about 1830 was the last Dansgaard-Oshur cycle, and it actually brought us out of a deeper ice phase. And that's why we're experiencing the modern warming here.
Yeah. So did you want me to summarize a bit about the superwave phenomenon?
Yeah. Could you describe where it's emanating from the center of the galaxy, how it's propagated, when it arrives? How do we know? And maybe some of the supernova data out in space where it kind of, there's like shells out there that are corroborating this information.
Yeah, well, we see this going on in other galaxies. This is something astronomers knew about even before I did my PhD dissertation, that you find what are called exploding galaxies or active galaxies where their cores are very luminous. They call them either Seyfert galaxies or quasars in the extreme case, end galaxies. And then they found that spirals, galaxies, tend to spend about 15% of the time in an active phase where their cores become active. And the other 85%, the cores are quiescent. So like currently our core of our galaxy is quiescent, but it can suddenly change, become active. And there was one galaxy they were looking at, suddenly its core flared up, and at first they thought it was a gamma ray burst. That's how fast it went from inactive to active, and yet it kept going and going. And so it turned out that was the onset of a galactic core explosion. That was the first time we'd ever observed that, but the scientists who did the observation weren't aware of the phenomenon of core explosions that can occur so quickly and frequently, to go from 0 to maximum, so they didn't mention that. So the thing is that this same phenomenon goes on in our galaxy, and it has done it so in the past. In fact, in the recent past, the most recent major one was around 14,000 years ago. And the core of the galaxy, what is it? It's a star, you can say, that's 4 million times the mass of our sun. And it's sort of at some point, it becomes active or sort of explodes, just like a supernova explosion. Like with supernova, you're dealing with stars that are 1 to 10 solar masses. Here you're dealing with something 100,000 times more to 1 million times more massive. And the energy output is tremendous. And it's the form of the output is in cosmic rays. It's not so much light. The light that you see from the explosion is generated by the cosmic rays that are being emitted, because the cosmic ray electrons, when they're decelerated or interact with magnetic fields in the galaxy surrounding the core, produce what's called
Paul,
Did you have a question? Yeah, I don't hear your question.
Yeah, you're breaking up you're breaking up a little bit, so I just wanted to jump in and see if that helps us out. But the question was, didn't we just recently determine a huge outburst at the center of our galaxy?
Nothing has happened recently of any magnitude. No.
I recall a paper where they determined there was an outburst from the center of the Milky Way recently. And maybe it's just corroborating the
Are they talking about a
14,000 year
past event?
outburst.
Maybe. I mean, nothing has been happening lately, except they talk about
Okay.
the activity of the center varying, the radio emission, and so on.
Well, and they claim it's a black hole. Is that your position, that the center of the Milky Way
No,
is a
that's a
black
wrong
hole?
concept, and it's easily disproven by even experimental evidence. To have a black hole form, you have to have a black hole, so to speak, within every single particle of matter. In other words, the core field has to go to infinity. It has to be a singularity. The gravity field of the particle has to be a singularity. And that's not the case. We've done probings of nucleons, neutrons and protons, with particle scattering experiments. And they found that, contrary to all their theories, the electric field in the center levels off, sort of like a haystack. So, and the same would be with the gravity field, because there's a phenomenon called Electrogravidix, which was just proven by Townsend Brown experimentally. It exists, and much of our space program, it has evolved from exploring this for space travel. So if the electric field plateaus, the gravity field will also plateau in the center. And subquantum kinetics, the kind of particles it produces, the solitons that are produced for the neutron and proton, their field plateaus also, becomes sort of haystack-like. And when you have something like that, where the field sort of goes, the gradient of the field goes to zero towards the center, that means the attracting force will go to zero. And so if you have gravitational attraction between particles, that attractive force goes to zero as the piece of matter, as this material collapsing mass or whatever gets more and more compact, and so it'll never produce a black hole. And then there have been other people that have shown problems with the black hole theory, other astronomers, and they published papers on this. They said, suppose you did have a singularity formed, and suppose you started with standard theory, start with a star that was slightly football shaped, and if it was started collapsing, it would produce what's called a spindle singularity, and the ends of the spindle would be outside the event horizon of the black hole, which means it could radiate infinite amounts of energy into the universe. And they said if that was the case, the universe would have been destroyed. So the fact that we're still here means that the black hole theory has a major flaw in it. And that's one. There's other
many
disproofs too, that I discuss in my book.
Yeah, many mathematicians can disprove it using math. And also, there's problems you run into if you're considering a Big Bang universe relative to an infinite universe. And the whole concept of red shift is complete nonsense. It's still we're still holding on to the idea that red and blue shift somehow determine that the universe is expanding. But with the data we have now, it doesn't show that at all. It shows equal amounts of in and out. And what do you think about that, Paul?
Well, the data shows that it's no expansion at all, that it's misinterpreted as being expansion, that it's an energy loss of the photons traveling long distances through space. They just lose energy as they do. The frequency changes. Like when something loses energy, wavelength becomes longer, so it changes towards the red. In fact, it does so in quantum jumps. Now, that's something the Big Bang theorists would have a real difficulty with explaining how you'd have expansion changing in jumps, quantum jumps. It would be totally ridiculous. But it's totally understandable for something losing energy that it would go from one step to the next as it lost energy. Yeah.
And the easiest way to explain a lot of this is some objects they thought were like 13 billion light years away are actually quite close. And there was just being occulted by some gases or dusts. And the whole concept of redshift is still being taught, though, from the base level up as if it's a fact. So, I mean, it seems like we have 30 years to go.
Well, none of this impacts on the superwave theory. This is sort of background information put in context.
Yeah.
There is an alternative cosmology where you can understand the universe in a better way without all the contradictions that astronomers have had. But for the superwave theory, about the only thing that gets into exotic physics is the nature of the galactic core. It really isn't a black hole, that it's what I call mother star or a supermassive star. And I've even estimated the diameter based on measurements that have been taken. Dolman et al. have done measurements in the microwave region to get a fix on the size of the emission. Excuse me. And they find that the size of the emission is smaller than the event horizon. In other words, they shouldn't be observing any emission if it was a black hole. The event horizon is larger than that. And so to explain it, they say, oh, well, this is something that's on the outside of the event horizon that just happens to be facing us. Just by chance, it's facing us. And we just happen to be looking at it when it's facing us. And so, but the problem is that if that was the case, how come it hasn't moved all these years, And because we know things go around the galactic core very quickly at that distance, it's probably making rotations of at least once every year of material going around, probably even faster if it was on the surface of the event horizon. Yet this is just sat there. So you come to the understanding it's really coming from within. Excuse me.
I muted your mic there. Hopefully you didn't get the jab. You didn't get the jab, did you, buddy?
No, this is ongoing. I've had this for a decade or more. Just a little tickle I get. So that's the only difference, is the way you view the core and come to an understanding of why it's cyclical. In my theory of subquantum kinetics, it's gets its energy not from gobbling matter like the black hole theory, but it's a center that produces matter and produces energy, and it has to do with the fact that the energy conservation law doesn't apply universally all over the universe. In fact, most of the entire universe violates that law. The redshift is one example of energy being lost spontaneously. And within the galaxy, our galaxy, and within galaxy clusters, you get what's called photon blue shifting. It's the opposite effect, where photon will increase its energy over time. And that has to do with the value of the gravity potential of the object. Now, in the case of the galactic core object, Sagittarius A star, 4 million solar masses, it's going gangbusters in there because the gravity field is so deep, and the gravity well controls the rate of energy increase, sort of like, think of a nuclear reactor, and you've got the control rods regulating the rate of the reaction. So in the cores of stars like that, it's like you pulled the control rods all out, and the reactor is going supercritical, and it's ready to blow soon. but as you put the control rods in, that will dampen down. Now, um, so right now the core is in a sort of stable state where it's able to radiate its energy, but at the same time it's growing in mass. The mass of the core is increasing because it's continually generating mass, and it will get to an unstable point at one point where because the amount of energy it puts out, it's related to the gravity potential it's producing. So as the matter produced is increased, the gravity well gets deeper and deeper until finally it jumps. All it takes is an outburst at one part of the core to get a runaway reaction, sort of runaway, and goes through the roof in one area, and it could ignite, so to speak, the whole core. And once that happens, it goes into the active state. And that can last anywhere from a year, the outburst, to 4,000 years. In the case of what happened during the extinction of Neanderthal man, it was a 4,000-year outburst. And during that time, it's expelling matter. So it's getting rid of matter. So eventually it gets rid of enough matter that it sort of calms down and goes back to the quiescent state. And then the cycle repeats. So that's what we're seeing here.
Based on the Fourier analysis, we've got multivariate cycles, or a hierarchy of cycles, something around 5,700 years. We got the 12.5 and the 25. Are those different magnitude cycles? Like the 5,000 year cycle is weak, the 25,000 year cycle is big, or it just depends. It's random.
Those are just cycles that they were able to pick out of the data. And you can see by looking at the Berlin 10 record, that's shown in my book, and fairly. We're continually getting better dating of the ice cores, so that hasn't changed too much. But you can see the magnitude of the outbursts, and there was a very strong one at the end of the ice age before this one. So it seems that every ice age is ended by one of these big galactic superwave events. And then every ice age is initiated also by a superwave event. And so, we've had 11,000 years now.
Yeah, that's the paradox.
We've had 11,000 years of warm temperatures, interglacial, and so we could suddenly find ourselves in ice age, if we had another event. So at the time I was working on my thesis, what I realized is that these cosmic rays that are emitted by the...
Now, when the superwave is coming at us...
yeah. When it's coming at us, what?
Go ahead. I didn't want to... is there a warning? Do we see, did the cosmic ray detectors go off the charts? Does our hair start to fall out? Or, I mean,
yeah, well, you won't have any warning.
Gradually increase? Will we see
you wouldn't
it coming
have
on the horizon?
Any warning, and suddenly the situation changes, like in the flash of a second. Suddenly there'll be this bright bluish white star-like object in the sky where Sagittarius and Scorpius constellations are located. That's towards the south. And the cosmic ray detectors will go gangbusters. And that's why it could be misinterpreted as a nuclear attack, you see. And most of the astronomical community is totally in the dark about this phenomenon. They're starting to wake up. They're starting to see in other galaxies.
Sagittarius A is far away. How many light years? Sagittarius A is a number of light years away.
Let's say it's around 26,000. Some people give different figures. Light years. So it would take 26,000 years for this travel towards us at the speed of light, but we don't see it till it gets here because all the light is producing along the way.
Right. So when we see
traveling with it.
Yeah, so when it illuminates, it's actually illuminating 26,000 years ago, and we're just
Well,
seeing it now.
actually, a lot of that is generated on the way. It's the cosmic rays are interacting with magnetic fields all along that journey, and they're building up sort of a shock wave of energy as they come, and all that you suddenly see. And the whole journey of 26,000 years is sort of we see it in super fast motion because it becomes superluminal looking that suddenly you'll see the outburst and suddenly it'll radiate outward and fill the sky. It would produce all sorts of phenomena around the solar system. Cosmic rays would impact the sheath around the sun. We have a magnetic sheath that's out there past the orbit of Pluto. It's about 100 astronomical units out there. So once it hits that, it's going to produce all sorts of light show out there of wave-like things radiating outward in circles. And it's going to start pushing that heliopause sheath inward towards getting it closer. And I did some calculations on the last superwave from 14,000 years ago and concluded it would have been pushed in as close as between Mars and Jupiter, around where the asteroid belt is. And along with cosmic dust, any cosmic dust that's out there would get pushed in too, and the solar wind wouldn't be as very effective to expel it. And once the sheath gets pushed in that close, it builds up enough momentum to just come right in and surround the sun and come in around the Earth. And Halloween is sort of a commemoration of events of the past, of past catastrophe. And I believe that the whole thing of the apparitions, like the witches going through the sky and the hobgoblin, the jack-o'-lanterns, all that is sort of trying to depict the strange phenomena people were seeing in those days. According to the Druids, that it was catastrophe of the past.
I just got back from a trip where we're looking at petroglyphs that corroborate Peratt's 2003 paper, Characteristics of a Z-pinch, and these are the unexplained petroglyphs that we believe are plasma discharge events witnessed in the sky by everyone, and they simply wrote them down on the rocks.
Your voice fades out.
Are you familiar with the Underbody Project?
I lose your mic from time to time. Yeah, I'm familiar with it. There's a fellow from Los Alamos.
Okay.
Perret. His name starts with a P.
Anthony Peratt.
Peratt, yes. And yes, he's concluding that they're looking at phenomena of sort of cosmic ray or like aurora type things in the sky.
Super aurora. So if you were to increase the output, which would simply be what you're saying, a galactic wave coming in, huge amounts of cosmic radiation going into the planet through our magnetic field, would create a super aurora. And we would see things. We're actually starting to see some things we've never seen before. We have a new aurora called Steve. The red sprites are increasing worldwide, so we have more ionospheric lightning that we're noticing. We even have a white aurora that has been witnessed in the last decade. So a blue aurora named Steve, a white aurora now. So the sky is definitely changing.
Well, it hasn't arrived yet, so I don't know what these are from, but when it arrives, you'll know it. Everyone will get down on their knees worldwide. I mean, it will be astounding. If you think that 911 was something.
Do you think that it causes a solar outburst when it hits the sun? Is there a super flare or a solar proton event?
It could cause the sun to go active. One thing that could do it is if there was a galactic gravity wave that traveled along with it a little in advance, that could cause a disturbance of the sun. And the other thing is, if the dust that was pushed in surrounds the sun and ends up falling in and ends up making a cocoon around the sun's radiation can't get out as easily, gets reflected back onto the sun by the dust particles that are surrounding it. And so the sun starts heating up and starts becoming more active. But it takes a couple months for that dust to come inward. So that's a delayed thing. I mean, we'd have some warning of that. The gravity wave thing, if that caused any problem, that would be very quickly. Then there's also the problem that the high energy cosmic rays, the very high energy, they're not stopped by the heliopause sphere. Heliopause sphere is a magnetic sheath that's around the solar system, but it's not able to stop the very high cosmic rays, which are at the forefront. And those would come streaming in, and the ones that hit the sun would end up blowing the solar wind, the plasma of the sun, the corona, would create a tail, sort of a tongue of fire would be coming off the sun. And this could be where the dragon myths come from. I call it the dragon mode effect, where if the Earth happens to be in the downstream alignment with that tongue of fire, really fry the surface of the Earth. And apparently it must have happened at times in the past. It's not always that it will happen.
That we found a petroglyph in the Zuni nation that was a depiction. Okay, everything just dropped out there. It was a depiction of the sun, Paul, and there was a plasma stream, a tail, one single tail coming off the top of it. Very bizarre. Never saw a petroglyph like that.
I would be interested if you sent me a picture of it. I'd be interested to see.
Yeah, absolutely. We're having a little bit of issues with the recording, so let's end the conversation here, and we'll pick it up a little later. I think we have a lot of information to marinate on. Do you have any predictions as to, because I believe that the next major event is happening in the next few decades. We're currently living what appears to be a magnetic excursion is ongoing. The magnetic field strength of the Earth has been reduced about 15 to 20% in the last 200 years, and it's accelerating. So clearly something is afoot here on Earth. And I think that is the reason why we have these new auroras, because our magnetic field is weakening. And surely the galactic cosmic, if a galactic wave is coming here and we have weak shields, that just makes the problem even worse. Isn't that true?
And even the wave itself, the cosmic rays themselves will end up collapsing the field because they get caught in the radiation belts around the Earth, and they produce a ring current, as it's called. And if you apply simple physics, this ring current generates a magnetic field opposed to the Earth's field and weakens the field. And we see this happening during solar outbursts. It's called the main phase decrease, where the magnetic field of the Earth decreases for a few days when it gets hit by a coronal mass ejection. But during a superwave, where you're talking about 100 times more particles could get trapped in that band, not only from the superwave, but if you had active sun, it could go even higher. You could actually, the field of the Earth could go down to 5% intensity, like it did during the extinction of the Neanderthals 42,000, 41,000 years ago. And I believe that was one of the main things why they were extinct. They had the extinction. It was they were unprotected from the cosmic rays and the UV. There was a lot of UV that would have occurred because of the ionization of the atmosphere. But I think that I agree with you. And I've always said we're overdue for a superwave. That there's a 90% chance something will happen in the next 400 years. But now there was this prediction of mystic Peter Danov from Bulgaria. It's posted on my website. It's posted on etheric.com. And he, before, that was in 1944, before we knew much about exploding galaxies. In fact, Seifert published his first paper on a cipher, Galaxy, that same year. And then described to a T a galactic superwave, called it a cosmic wave of energy coming and affecting all planets in the galaxy. And the date of arrival, it's not in the text of that prophecy of his, but people close to him said that he had felt it was going to arrive around 2029. So that would be 8 years from now. And I just got word from a reputable source who had talked with the person that he talked to that shared a story from a fellow who was quite wealthy industrialist who was taken into the fold of the cabal, the elite, so to speak, the shadow government. And they shared with him their plans about COVID. And they said, if we don't get 90% of the people taking the vaccine, we have even stronger measures that we're going to put into play. And he said that the whole thing was because they feared the arrival of a cosmic wave from the center of the galaxy. So somehow they're been tipped off. You know, how would they know the date? You know, and because they're in touch with extraterrestrials. And I don't know. This starts to get a little weird, talking about ETs and everything. But that puts in perspective the craziness that we have. If you want to know why has the world gotten so crazy, it's because it's this group of people that trying to maintain their control, their grip on the earth, and are afraid they're going to lose control when the superwave comes, which is true. You know, they're going to lose control.
Yeah, because, well, you and I have discussed that the fact that humans use only a small portion of their brain, and we know that cosmic rays affect genetics. We know that the only thing that can mutate genes are cosmic rays currently, and that it potentially this new cosmogenic environment will allow us to communicate better with humanity. So maybe we could defeat evil during this event, and they're trying to prevent that from happening. Right. Isn't that something that you and I talked about?
Yeah, I think all of this requires a critical mass of humanity being on the planet when this occurs, because there's a mass effect. There's a 100th monkey effect where everyone's is horrified by the same thing in the sky, and majority start praying. Let's say even at 50% or less were praying. It would be the first time that so many people have been praying at the same time. And they know everyone has psychokinetic abilities. This has been demonstrated in laboratory. And imagine that focusing that energy, group energy, sort of a peak experience of humanity, on deflecting the superwave. We could do it ourselves. We wouldn't need any gizmos or anything. We just use it with our minds. We could deflect the superwave. Could will it away.
You just... will it away. That's all we got to do. Will it away.
That is the sign that we passed the test as a human civilization, because this happens to all civilizations in the galaxy. And the ones that are the newcomers who they haven't proven themselves yet, like us, that is the major test. And if they can survive the superwave, and so this is, I believe, how it will
absolutely happen. Mind-blowing.
It's what they call the ascension.
Mind-blowing ending to the podcast. Always
you hear about the ascension.
Yes.
And it's always in the Bible and all the spiritual writings. A catastrophe is usually connected with some major spiritual event, transformation of humanity. And I think that's the reason.
Yeah, we were just with some Zuni elders, and they were telling us their creation myth, how during the last catastrophe, the ant people emerged from the Grand Canyon and helped them rebuild. And this could have been. They said that they were interdimensional, that they were only allowing the Zuni to see them during the transition So maybe during these high cosmic ray periods, other dimensional beings that have already ascended come down here to give us a hand. It's
Peace Corps work.
Sticking up the hair on my
Yeah.
back. Yeah, Peace Corps work. So we're going to have to split this up. The last 10 minutes of this podcast are going to go over on Rumble, where we can talk about aliens and vaccines. And the first half, we're going to be putting up on Magnetic Reversal News, directing people over to the good stuff. Paul, it is always a pleasure to talk to you, and my mind is always blown. We're like-minded in so many things, and I just, it's like we just met, and we're thinking the same stuff. It's fascinating, and I appreciate you as a scientist. Do you have any final words?
No, till next time. Well, will it be before Christmas or after Christmas?
It's up to you, but you can always check Paul out over at the starburstfoundation.org and his awesome website, which is etheric.com.
Mm-hmm.
Okay, so go check those websites out. Those links will be below. And Paul, we love you.
Okay, thank you. Bye-bye.